Greetings, class, and welcome to installment 2 of videos from section 4.4, where we're continuing our discussion of hypothesis testing and the meanings of the different types of errors that we can make when we do hypothesis testing. So now that we've introduced the idea of type 1 and type 2 errors, let's look at some applications. I've created a few exercises here, some of my own, one from the textbook. And we're going to take a look at these here. As we take a look at understanding type 1 and type 2 errors. So for our first question here, suppose that the biologist is looking for evidence that the proportion of snails that live more than 2 years is less than 30%. They want us to write the rival hypotheses that correspond to this situation and to explain what it would mean for the biologist to end up making a type 1 error here. So first of all, in writing the hypotheses, we have to decide what parameter is involved. And we see in the question that we're talking about a proportion, the proportion of snails that live more than 2 years' time. Now, what the biologist is looking for evidence for is that this proportion is less than 30%. So that's going to form our alternative hypothesis that the proportion P is less than 30%. That's our alternative hypothesis. Now, what would the null hypothesis be? Well, the null hypothesis would be that the proportion is exactly equal to 30%. So in this scenario, those are the rival hypotheses that we are taking a look at. What would it mean for the biologist to make a type 1 error? Well, we remember that making a type 1 error means rejecting the null hypothesis when it's in fact true. A type 1 error occurs when someone rejects a null hypothesis that's actually true. So in this context, what would that mean? That would mean that they believe that there was evidence for the alternative. They believe that the proportion of snails that live more than 2 years is less than 30%. That's what they've concluded. However, it's actually true that the proportion of snails that live that long is actually 30%. So they've made an error by concluding that the proportion is less than 30%, going with the alternative hypothesis, when in fact the null hypothesis was really true, that the proportion was precisely 30%. That's an example of an application of interpreting the meaning of errors. For our second problem, I'd like to take a look at a problem from your textbook, and this is exercise number 144 from your text. It says that exercise 439 describes a possible study to see if there's evidence that a recorded phone call is more effective than a mailed flyer in getting voters to support a certain candidate. The study assumes a significance level of 5%. And they're going to ask us a number of questions about this scenario. So we have some rival hypotheses here. The alternative hypothesis here, what they're seeking evidence for, is that the recorded phone call is more effective than the flyer. So to go with the alternative would be to say that the phone calls were more effective. What would the null hypothesis be? Well, it would be that there's no difference between the two, that the recorded phone calls were exactly as effective as the flyers for getting voters to support a certain candidate. So in this circumstance, let's take a look at our questions. Part A asks, what would the conclusion in the context of the study be if the p-value for the test turned out to be 0.027? So to come up with the answer to that, we've got to take a look at this p-value, 0.027, and compare it to our significance level. How did the two compare? Which is smaller, which is larger? In this case here, we can clearly see that the p-value, the 0.027, is smaller than the significance level of 5%. So since that's the case, we're going to reject the null hypothesis. Since the p-value is lower than the chosen significance level of 5%, we're going to reject that null hypothesis. And what does that mean in the context of the study? Well, in the context of the study, that means that we're concluding that there is evidence that the recorded phone call is more effective than the mailed flyer in getting the voters to support the candidate. Rejecting the null hypothesis means that we believe the alternative, and that would be that the phone calls are more effective than the flyers. Part B asks, if we reach that conclusion, the conclusion that the phone calls are more effective than the flyers, what type of error are we possibly making? Are we possibly making a type 1 error or a type 2 error? And what would that mean in this situation? Well, remember that any time that you choose to reject the null hypothesis, then you are possibly committing what we call a type 1 error. Type 1 errors can be made when you reject the null hypothesis. There might actually really be no difference in the effectiveness of these two approaches. The phone calls might be exactly as effective as mailed flyers in getting people to support a candidate. But if we've concluded that the phone calls are more effective when in fact there's no difference between the two, we've made a type 1 error. And that would be the case in part A with that small p-value. Part C then asks, well, what would the conclusion be if the p-value for the test was 0.18? So they've changed the p-value here. We're no longer saying that it's 2.7%, we're now saying that it's 18%. How does that 18% compare now to our significance level of 5%, which is smaller, which is larger? The p-value is larger than the significance value here. And whenever that's the case, when we have a larger p-value than our significance value, we're going to fail to reject the null hypothesis because the p of 0.18 is bigger than the alpha of 0.05. We'll fail to reject the null hypothesis. That means here that we're effectively concluding that we don't think that there's significant evidence that there's a difference in the effectiveness of these two approaches. D asks, well, in that conclusion, what type of error could we possibly be committing? Now, the answer there is a type 2 error. If you fail to reject the null hypothesis, when in fact it was false, then you've committed a type 2 error. What would that mean here? Well, we said in part C that by failing to reject it, we were concluding that the two approaches were effectively equivalent, that there was no difference in effectiveness. But maybe it is the case that phone calls are more effective than flyers. If phone calls really are more effective than flyers, but we've concluded there's no difference, then we've made a type 2 error. And that'll happen anytime that our p-value exceeds our significance level and we decide not to reject the null hypothesis. There's always the possibility of making a type 2 error whenever you fail to reject the null hypothesis. For one final problem here now, let's take a look at question number 3. Question number 3 concerns a hypothesis test for means. The null hypothesis is that the mean mu is 75. The alternative hypothesis is that the mean is larger than 75. Someone wants to see if there's evidence that this population mean exceeds 75. Well, they took some data and they found a sample statistic of 75.462. That's a little bit larger than 75. When they make their randomization distribution, and we can see that here plotted out from StatKey, and they find that sample statistic of 75.462, StatKey tells us that the p-value for this right-tailed test, And it is right-tailed because we're checking to see if the mean is bigger than 75. StatKey tells me that the p-value for that is 0.116. So the question is, given those results, given this sample mean and given that p-value, based off of our randomization distribution, what should we conclude and what type of error might we have made uh, in drawing that conclusion? And we're told that we're supposed to assume a level of significance of 10% for the test. We can see the results there that have just appeared on the screen. In this case here, the p-value of 0.116 is larger than the significance value of 0.10. It's a little bit more than 1% higher. Because the p-value is larger than the significance level, that means that we're going to not reject the null hypothesis. We're going to fail to reject it. We're going to be conservative. Now, in doing that, it's possible that we've made what we call a type 2 error because we failed to reject the null hypothesis. It could be that maybe the null hypothesis is false. We don't know. We believe that we're saying that we don't think there's enough evidence for the alternative hypothesis, but maybe that alternative hypothesis is true. Maybe the mean really is larger than 75. If the population mean really is bigger than 75, but yet we failed to reject the null hypothesis, then we've committed a type 2 error. Those are 3 further applications of talking about type 1 and type 2 errors. And I hope these have been instructive as you're working on solidifying your understanding of the meaning of those terms. With that, we'll sign off for this particular video today. I wish you well.